Welcome to AutoSens, the world's leading community for ADAS and autonomous vehicle technology development. We create best-in-class events, training, and information for the purpose of connecting the global community of scientists, engineers, and other automotive industry experts. Today, we are joined by a handful of representatives from Samsung Semiconductor. So we are calling this, as part of AutoSens, our Samsung Semiconductor Roundtable. So the way that this will work is that I will ask a question, and then each member of our Samsung Semiconductor Roundtable will come on. They will say their name and introduce themselves, and then answer each question. And it's pretty exciting because we're going to be talking about the latest trends in automotive electronics. We're also going to talk about the Samsung Foundry and then how Samsung is preparing for an autonomous driving future. So let's begin with the first question. How does Samsung intend to support the latest trends in automotive electronics towards software-defined vehicle architectures and achieving higher levels of autonomy? And to add on to that, what we want to explore is, what does Samsung bring to the market?
Hi, everyone. Thank you, Carl. My name is Kelvin Low. I'm the Vice President of Samsung Foundry's Market Intelligence as well as Automotive OEM Business Development. So glad to meet everyone. Great question, Carl. So Samsung Semiconductor, we are uniquely positioned to provide really a true one Samsung value proposition when to support the latest in emerging autonomous vehicle and next generation EVs. Throughout the conversation today, you will see that we have a wide-ranging solutions covering automotive memories, SoCs, displays, advanced packaging, sensors, and all the way to foundry service, right? And obviously, to do this well, we collaborate closely with the automotive OEMs as well as the rest of the automotive supply chain, deeply to understand their requirements for future products and vehicles, which can be broad-ranging again from necessary sensors like CMOS image sensors, LiDAR, radar, to SoCs that manage critical zonal functions, as well as different levels of ADAS, including in-vehicle infotainment and cockpit domain controller chips. And then all cars needs a lot of memory as we process more data, right? So we provide also automotive qualified memory chips where density and performance growth are paramount for faster processing while keeping also to the given power budget, right? And then to also meet demands for more purpose-built silicon, especially for certain applications, for example, full self-driving chips, we provide a full service foundry offering, which includes also turnkey end-to-end ASIC design support.
Expanding on that idea, what we want to explore now is, how is Samsung planning to meet the growing demands of safety-oriented vision applications in automotive?
Thank you, Carl. My name is Leo Lautenschlager. I'm the FAE Director for CMOS Image Sensors in Detroit, Michigan. Well, from our extensive engagements in the market with OEMs, Tier 1s, and a multitude of ecosystem partners, as well as from our internal research, we're well aware of the needs and wants of the market. We are carefully weighing in and exercise healthy decision-making. We're actively working to support the demands for better performance to enable higher levels of safety and autonomy by increasing sensor resolution, dynamic range, better low-light performance, and other features, while not ignoring the general trends towards commoditization in the market and the need to keep cost under control so the blessings of vision systems can benefit drivers of all vehicle classes. We strive to deliver best-in-class performance at a cost which meets the demands of the global market. We are uniquely prepared to provide sufficient and secure manufacturing capacities to meet the future demand of the market. Our mainly internal supply chain, designed to avoid sensitivity to uncontrollable events, assures stable supply while differentiating with internally controlled, developed, and advancing manufacturing features.
So that's a look at how Samsung intends to support the latest trends in automotive electronics, and then also how they are planning to meet the growing demand of safety oriented vision applications in automotive. Now, we take the conversation to the Samsung Foundry, and in particular, how does the Samsung Foundry support automotive customers?
Samsung Foundry has been producing wafers, a lot of wafers for automotive customers for multiple years, covering different applications like MCUs, power management chips, battery management chips, infotainment vehicle and cockpit chips, and including sensors and the most advanced ADAS chips, right? We are a market leader, for example. We supply 100% chips for a leading US OEM, full self-driving SoCs. We also a 100% supplier for a leading fabless company for their 8 nanometer ADAS SoC. And just to call out another, we are also another 100% foundry supplier for a leading fabless SoCs, right? Again, we do have a very comprehensive process roadmap to service all these different applications. We see again a lot of different applications that require performance and yet power sensitive. For let's say applications like power management or battery management, we also provide differentiated 200 millimeter wafer technologies that support, for example, high voltage with embedded non-volatile memory options. Yeah. As we discussed also deeply with customers for basic applications to zonal controllers like MCUs to kind of crossover MCUs, we provide also various embedded non-volatile memory, including embedded flash and embedded MRAM technology. Right. Um, Again, to accelerate automotive chip designs, the foundry not only provide process technology and run wafers, we need to prepare design collaterals that are automotive certified, right? So, which includes design methodology that supports DFT and zero DPPM. And then to prepare again building blocks, prepare foundation IPs to critical interface IPs. They are all fully automotive ready as well. We work closely with our packaging business unit to also provide comprehensive packaging portfolio that includes wafer level packaging, ball grid array packaging, lead frame packaging, and so forth, right? And to top it off, right, AutoSens in Detroit, we do have manufacturing facilities onshore in the US. So hopefully you can see that we are indeed a true one-stop shop foundry solution provider for automotive chips.
Now that we've had a more in depth look at the Samsung Foundry, let's talk about the increasing adoption of higher level ADAS and automated driving. And in particular, what are some critical technology requirements that Samsung Semiconductor has seen coming, maybe from the perspective of the OEMs and the automakers?
So, hello, my name is Ryan Suzuki. I'm the product marketing director for automotive memory. So aside from a broad product portfolio, there are two main critical requirements we've seen from automotive OEMs. First, we see an overall density growth in memory content per ADAS or autonomous driving system. As the L2 and L3 systems become more mainstream, so DRAM density is going to grow from an average of 4 gigabytes today to 31 gigabytes by the end of the decade. While storage will grow from 143 gigabytes to 713 gigabytes over the same time frame. Now, as higher autonomous driving systems of L3 and L4 come into the marketplace, we actually see that those densities are going to be more like 192 gigabytes for DRAM and nearly 2 terabytes of DRAM for storage. The second requirement we see is the need for higher performance. Increasing amounts of data must be processed and stored as levels of autonomy increase. This is driven by the increase in number of sensors as well as a higher sensor resolution. L2 employs anywhere from 2 to 10 sensors per vehicle, while L5 systems will require upwards of 30 sensors per vehicle. So this is going to obviously require faster memory interfaces. Today for DRAM, LP4 is the mainstream memory. Over the next few years, autonomous driving systems will transition to LP5, which operate at upwards of 2 times the LP4 performance at 85 or even 9600 megabits per second. On the storage side, we're seeing the migration from eMMC to faster interfaces of UFS and NVMe4 SSDs. which support over 13 times the performance of eMMC. So to ensure these autonomous driving systems are realized, Samsung Semiconductor is partnering with automotive OEMs as well as SoC suppliers to ensure our future products support the requirements for next generation systems.
As we expand more on this conversation as part of our Samsung Semiconductor Roundtable, as part of AutoSens Detroit 2024, let's look at what Samsung is doing to prepare the public for the autonomous driving future.
That's a very good question. Thank you, Carl. Hello, everyone. My name is Harold. I'm a field application engineer for the automotive SoC at Samsung Semiconductor. So to answer that, guided by our vision to inspire the world, create the future, Samsung is continuously developing a range of solutions to support autonomous. When you take it into account, our ecosystem, that is our many partners, customers, and business units, there are really a very few technologies related to autonomous driving that Samsung does not have hands in. There are a number we develop in-house, of course, and those are memory, image sensors, foundry, and system on a chip, aka SoC. So the Exynos Auto SoC family is a highlight as it brings together a versatile set of solutions into one chip that can power everything from mid-range to high-end, ultimately even to fully autonomous vehicles. The Exynos Auto SoC will be the core for the HPC, the high performance computing systems, aka central compute, which will provide sensing, will make decisions, and will maneuver vehicles without human involvement. To manage this, Samsung chip has a suite of processors, including powerful multi-core CPU, all new console-level graphics, powerful GPU, and a versatile NPU that can analyze all the sensor inputs. Up to 12 sensors can be connected to this chip, all streaming at the same time. So it is more than enough to aggregate all the data and make decisions accordingly. And the chip features a safety system that can monitor the overall status of the system to ensure the safety of everyone on board. I want to stress the last point because while Samsung is always pushing boundaries and creating new ideas, at the forefront of everything we do here is to focus on improving human lives, protecting it, and also helping to make people happy.
Our Samsung Semiconductor Roundtable, part of AutoSens Detroit 2024, we've looked at how Samsung is addressing and supporting the latest trends in automotive electronics. We've also looked at how Samsung is planning to meet the growing demand of safety-oriented vision applications in automotive. We also got an in-depth look at the Samsung Foundry. We looked at how Samsung is preparing for the increasingly higher levels of ADAS and autonomous driving and what is on the horizon there for OEMs and automakers. And then lastly, but perhaps most importantly, we talked about how Samsung is preparing for the autonomous driving future with a focus on improving human lives. So as we conclude our Samsung Semiconductor Roundtable, we want to take just a last minute here to hear some final thoughts from one of our panelists.
Yeah, as you can see, the Samsung Semiconductor team is extremely excited to see all the innovations that's happening in this automotive electronics and the future of autonomy for electric vehicles. We prioritize safety above everything else. At the same time, we want to enhance user experience, right, for the next vehicle that will be out there in the marketplace. You could see us also providing end-to-end solutions for different components in the car, from a simple element like an MCU all the way to the next most power efficient and high performance memories. We provide SoCs as well that handle different functions, so from cockpit zonal controllers to all the way to a higher level ADAS. And for sensors, not to forget that, cars these days come with multiple image sensors, and that's just growing as we have more intelligence built into vehicles. And to top it all, we also have Foundry offering that covers all different aspects of how we can provide you silicon that are differentiated, right? Extremely exciting times, and we are glad to see you at AutoSens show soon.
For more information on Samsung Semiconductor and everything discussed here as part of our roundtable for AutoSens Detroit 2024, see the links in the description or visit auto-sense.com. That's auto-sense.com. And for more interviews like this, subscribe to our YouTube channel and follow AutoSense on LinkedIn. In Detroit, on behalf of AutoSense, I'm Carl Anthony.